project has two components. One is that it deals with the generation of a European wind atlas. The second component is understanding the meteorology and the flow patterns in complex topography.
The biggest experiment is the Perdigão experiment, where we have a lot of collaboration with other countries like the United States, many countries in Europe. So it's a huge atmospheric experiment, one of the largest that I know of. The purpose of the whole thing is be better to understand the wind, because we want to make sure we estimate the wind resources for wind energy more precisely.
As dificuldades da realização de um projeto desta natureza foram imensas. A primeira condição que procurámos satisfazer era ter o apoio das entidades locais no sítio onde isto viesse a ser realizado. E o local foi um local condicionado pela forma da orografia. Nós sabíamos que precisávamos de uma montanha com determinadas características, duas cumeadas paralelas. Em Portugal só existia num local único e foi necessário, isso teve início em 2006, logo contactar as autoridades locais, explicar-lhes o que é que pretendíamos fazer e ter o apoio dessas mesmas autoridades locais. A importância da experiência e a utilidade de uma experiência desta natureza é muito dependente da quantidade de pessoas que consegue mobilizar e dos recursos e todo o equipamento científico que é possível colocar no terreno. E por isso, todo o trabalho de planeamento, realização e organização de Perdigão 2017 demorou-nos mais de 10 anos. Ela basicamente teve início em 2005, levou-nos tempo a explicar às entidades financiadoras a necessidade de agrupar os grupos que na Europa têm interesse nestas áreas científicas.
Esta campanha experimental decorreu em Vila Velha de Ródão, na Serra das Talhadas e na Serra de Perdigão. Os equipamentos utilizados nesta experiência vieram de uma pool onde vários países, várias instituições tiveram a sua contribuição. No caso português, em particular, a nossa contribuição materializou-se em alguns equipamentos, mas sobretudo em infraestrutura, torres de suporte, infraestrutura elétrica, infraestrutura de comunicações, enquanto que outros países trouxeram fundamentalmente instrumentos de medição. A conjugação de todos estes equipamentos foi pré-estabelecida num plano científico. A partir do momento em que se fez um layout, começou-se a desenhar a infraestrutura necessária para que eles pudessem operar.
The use of scanning wind lidars, machines based on lidar technology that can measure the wind far away, up to many kilometers away from the instrument, and do that in a coordinated fashion so that we can measure the flow over these hills here in Perdigão. On top of all the wind scanners, all the lidars that measure the wind remotely, we have 50 meteorological towers measuring the wind, the three-dimensional wind vector, more than 20 times per second, and we have more than 180 instruments doing this continuously for the whole campaign.
The fact that this experiment is happening right now in 2017 is very fortuitous. If we attempted to do something like this 5 years ago, it would not have been possible. So some of the instruments that are used here did not exist 5 years ago, or if they did exist, they were multi-million-dollar instruments that only existed, one or two of them in research labs around the world. The fact that commercial technology has advanced allowed us to, basically cover this valley in scanning instruments that measure pretty much everything. This is the right time to do an experiment like this. So this valley is important because it is small enough that we are able to have a dense enough network of measurements, and it's big enough, so it's kind of a Goldilocks situation where if it was much bigger, it would be harder to have a good density of measurements, and if it was smaller, then we wouldn't have as interesting of complex flow. So because these ridges are 200 meters essentially above the floor of the valley, then there's the opportunity for, as the atmosphere gets layered and we have warm layers above cold layers at night, there's the opportunity for interesting flow phenomena to develop. So we're hoping that we'll be able to generalize the things that we learn in this valley to other locations that might be bigger or might be smaller, but we have the ability to get enough information here.
The project has two durations. The European part has 5 years in their project, and now United States part is 3 years, with experiments lasting 6 months for a reduced operational period we call the extended operational period, and also for 1.5 months we call the intense operational period.
It is very exciting to participate in an international project like this. We are testing a lot of new instruments, an unprecedented number of towers and sonic anemometers. We are really aiming at studying the flow, turbulence, and also the atmospheric stability. Our particular instruments have been working very well. We have really unique data sets of wind, temperature, humidity, and turbulence profiles. In the evening when the sun is setting and in the morning when the sun is rising. We call these the transition periods of the atmospheric boundary layer, and these are the times when the models have the biggest problems in predicting what exactly is happening in the atmosphere. So by collecting these data sets, we can hopefully improve future forecasts of the conditions during these time periods.
Este projeto tem uma campanha em Perdigão de grande dimensão, uma campanha observacional de grande dimensão. Um ponto importante dessa campanha foi o lançamento de balões meteorológicos. Além dos balões estratosféricos, esta campanha também contou com balões cativos e eu pude ver uma radiosondagem, ou seja, um perfil da temperatura e da umidade e do vento, poucas horas antes daquela trovoada ter acontecido aqui. Isso permite-me ter um conhecimento do estado da atmosfera umas horinhas antes da ocorrência daquela trovoada, como eu, em geral, não tenho. Eu até agora só poderia olhar para análises de modelos ou previsões de modelos e naquele momento eu pude, no meu país, ter acesso a um perfil de facto observado do que se passou na atmosfera pouco antes de ter havido aquela trovoada.
This project is important for many different reasons. The first, most obvious reason why it's important is because we're learning so much about airflow and complex terrain. So there has never been an experiment before like this that has given us so much information, so densely distributed in such a small area. So we actually have the possibility of measuring almost everything that we need to do in order to improve the models that simulate flow in the atmosphere. One of the other exciting aspects of this project is that we were able to bring a tethered lifting system here that carries probes that measure turbulence at very high rates. In order to make these very fundamental turbulence measurements, it requires many hands and a lot of attention. And what we're trying to understand is the small fundamental details of how turbulence is generated and then how it is dissipated. And this is important for understanding how we make simulations of atmospheric flow. There are some problems with some of the fundamental physics included in those models, and these measurements are going to help us answer those questions. And so being able to make these measurements here in complex terrain where we have so many other supporting measurements is really valuable.
Well, the expectations are that we will have a long-lasting, very long-lasting data set which lasts for many, many decades, where people can use to study.
In science, I don't think we ever want to say that we have a final result. I think that we do science because we're interested in questions, and every time you answer a little piece of one question, you discover another larger question. It's like how a cloud starts to form and then it balloons and gets bigger and bigger. So I hope that we never have a final result from this project. I think that we'll learn some definitive things, and I think that we'll be able to improve our numerical models that we use to simulate the atmosphere, and so that will improve weather forecasting. But I hope that we will continue to ask more questions and be able to answer them with a data set like this.
A experiência anterior que nos guiou e que pretende ser substituída e trazer coisas de maior valor, maior detalhe, foi a da Ascarvine, que teve lugar em 1983, portanto estamos a falar de medições feitas há mais de 34 anos. Encontramos uma grande utilidade nesses dados. Eu diria que é esperável que no caso de Perdigão 2017 o mesmo aconteça, não é?